Alright, so this is just going to be a quick statistics overview showing you how to calculate means and standard deviations, as well as graphing those means and standard deviations to be able to determine if there's a significant difference between your data sets, or in other words, to figure out if there is a difference, a significant difference between the different levels of your independent variable or the groups that you tested. And I'm going to do this with a sample set of data, but you can use this video as a guide for your own data analysis, because I know you all did your own science fair projects, your own individual science fair projects, so you have different sets of data. So at least this we can talk about together, and then you can use this kind of like a cheat sheet for your own data analysis. And that you can also use this later, since it's posted online, to help you in case you don't get through all your data analysis during our short time together. Alright, so this is a small sample set that I put together just to illustrate a couple of ideas and the reason why we have to do statistics. I'm sure you already know this, but I just want to review this before we start with our data analysis. As we look at these two samples, they're small samples, there are only 4 data points in each sample, and we don't have to have the same number of data points in each sample to do statistics, but this sample is probably too small to do strong statistics to, but it's going to still illustrate the points that we needed to. So if we look at those two samples, we look at their averages that are calculated below, we see that the mean for sample A is 6.25, whereas the mean for sample B is 6. Well, those are close, and if I asked you which one, which group A or group B, performed better, you might say sample A, because that is a higher average or a higher mean. Well, if you were to say that, you may be wrong, and it's because if you look at the data points, we see something quite striking. Sample A has a wider spread of the data, and sample B has data points that are more closely clustered. So if you look at that a little more closely, you see sample A has a range of 2 on the low end and 10 at the high end, whereas sample B has all the values lie between 5 and 7. So they're more tightly condensed. And that has something to do with reliability and how often or how closely we see those data points. And if things are more spread out, then we might have outliers that really skew that average value. So let's say you're in class and you ace that test. You get 100% on the test, but all your friends in the class, all your buddies, by buddies I mean all of your classmates, fail that test. Well, if we average those values together, then your score, your 100% on that test, is really going to skew the average, and that average value really doesn't reflect how well you did on it or how poorly your friends did. So we have to look at another value that we call standard deviation. And you should write this down, that the standard deviation is a value, it's a measurement that represents how spread apart the values are in the sample from the average. Now it's not the same as the range, because standard deviation takes into account how many values are really far away from the average and how many values are really, really close to the average. And there's a big fancy formula that we use to calculate standard deviation that you do not need to know, fortunately, because our friend, our buddy Excel will be able to do that for us. So let's go ahead and launch into that, and we're going to start to calculate our standard deviation values and graph them. Okay? And I'll explain a little bit about what's happening with our standard deviation as we go through it. Alright, so what I have here is a new sheet that goes over, that has the raw data for the number of chocolate chips from our Safeway brand and Chips Ahoy brand. Now this may not be the exact data, and likely is not the same data that you collected at the beginning of this session. So this is just to demonstrate the process by which you're going to do this, and so that you have an electronic resource for that. So here's my raw data, and there are two things that we need to be able to calculate immediately, and that's the average or the mean and the standard deviation. Now we want to make sure that we have a proper title for our data table. So I'm going to go ahead and write in this is raw data of the number of chocolate chips. The number of chocolate chips for Safeway and Chips Ahoy. And remember, we're trying to answer the question, which brand has more chocolate chips? Now, if we looked at our first sample, we would see, if we were only comparing trial 1 to trial 2, we would see, oh, Safeway has more. Trial 2 says Safeway has more. Trial 3 says Safeway has more. Same with trial 4. 5 says the other way. 6 says the other way, so Chips Ahoy has more. So what we really need to do is find out what's the trend, what's going on, and that's what statistics helps us do. So I'm going to go ahead and put this in here as we can call this processed data. And this is really what needs to go on your board, not the raw data, unless Ms. Gunderson says so. But really, the process data is what needs to be graphed, not the raw data. So this is the process data, and what we need to put in here is mean and standard deviations of the number of chocolate chips per brand. It's kind of getting lengthy there. So what I'm going to go ahead and do is type in my two brands, and then write in mean and standard deviation. By the way, I would say it's pretty important that you format your data in this way as you put it into Excel, because Excel is going to read certain values from certain cells, so you need to format it in this way. So there should not be an extra column between Safeway and Chips Ahoy. I'm not sure why a lot of my students end up putting a space between them, and that really messes the process up later, and then they have to go back and fix it, and it's a time-consuming process. So just go ahead and put it in here like this. Now I don't know if you know how to do formulas, but I'm going to go ahead and select this cell that I want it to calculate the average in, and click FX or insert function, and I want the mean or the average. So it's right here at the top. I'm going to go ahead and double click it and tell it what cells to pick to calculate the average. So I'm going to run over here to this little blue button, click on it, select my Safeway data points, and then click on this blue button again, and then hit OK. And it gives me the average value. Now if I wanted to do the Chips Ahoy, I could do the same thing for this cell and pick the Chips Ahoy data. Here's a shortcut. Drag, sorry, I'll show you what I'm doing. I'm going to hover over my cell, over the little black square in the bottom right, until I get the crosshairs. Click, drag over, and what Excel has done is read this data from Chips Ahoy to put into the Chips Ahoy column. And that's why we format it this way. And then we've got standard deviations that we need to put in. And again, this is calculating how far the data points are from the average. So we're going to go back to FX. It's an insert function. I have this value here, STDEV, because I use it quite often. But if you don't see it on your computer, you can just type in STDEV, standard deviation, and go. And it should be the very top hit. There's several standard deviations. Pick the most basic one. Double click, and then you need to pick the cells that you want it to calculate standard deviation from. So again, click on the blue button, pull down on all the cells, and click on the blue button again, and hit OK. And then we can do a little shortcut again Now, we've got lots of decimal places here, and that's not what we need. So I'm going to go ahead and select them all, right-click, go to Format Cells, wait for it, go to Number, say I want 2 decimal spaces, and hit OK, and it's going to round my values all to the same number of decimal places. So it's not quite the same as sig figs, but this is okay. So that'll work for us. Now, we've calculated our means and standard deviations. When we look at the averages, they're close, but our standard deviations are also very close, if we round 5 and 6. So we need to graph these to see if there really is a significant difference between the number of chocolate chips in Safeway, and if there's a difference between Safeway and Chips Ahoy for the data that we collected. So what I'm going to do is select these 4 cells with my titles and the averages. Click on Insert, Column, Bar Graph, and automatically what I have graphed, I have my different groups at the bottom. I can delete this, and before I do anything else, I need to go ahead and make sure I have my title and my axes labeled. So I'm going to go. Oh, sorry, I was talking while I did that. I clicked on the graph, clicked on Layout, and went to Chart Title. And I'm going to center mine, let's do above the chart. And what I have here is mean values, or let's do mean number of chocolate chips per brand. And we'll leave it like that because that's what our data shows right now. Okay, but there's something else that we need to do. I'm going to click back on this chart, go back to Layout. I'm going to put an axes title in. So on my x-axis, I'm going to add brand of chocolate chip cookies. And then I need to, on the y-axis, add number of chocolate chips. Now if we had units, like if we weren't measuring number of chocolate chip cookies but the mass of the chocolate chip cookies, we'd make sure that we put grams here in our axis label. Alright, so we've got our axes labeled, we've got our title, now we need to add the standard deviations. So if we click on our chart again and we go to we're back into Layout, there's a button over all the way on the right that says Error Bars. If you click on the Error Bars button, you get a drop down menu, and there are several here. There's one that says Error Bars with standard deviation. Do not pick that one. That's going to, for whatever reason, Excel does not do that appropriately. So what we actually need to do is go to More Error Bar Options. When you click on this, you get a couple of options, and I'm moving this out of the way so that I can still see my standard deviation values here underneath. And I want error bars above and below, and I do want caps on them. I want these lines. I do not want a fixed value, I want to customize it. So I click on Custom and Specify Value, and I want the error bars to go above the average, this many, for each of my data points, and below the average, this many, for both data points. And then I'm going to click on OK, and close. And if we look at our graph now, we have added something. And we've added 1 standard deviation values. Let's make this a little bit bigger. So and you could resize this graph however you needed to. But we have added, let's see, sorry, this is just bothering me. We've added the standard deviation bars, and let me help you understand how we interpret them. On the left, we see our error bars that go above and below the average value. And what we're allowing that to, what we're saying is that most of our data falls between those two caps of the error bar. And when I say most, when we talk about 1 standard deviation difference, we're actually talking about 68% of your data. So 68% of the time when you get a random Safeway cookie, you will have a value of chocolate chips that falls somewhere between the values that fall within that black line. The same way that 68% of the time you pick a random Chips Ahoy cookie, you're going to get a number of chocolate chips that fall between those black lines. Now 68% is not all that high. That's a standard for our graphing procedures, but you could even go to 2 standard deviation values. You could double these values and put them in there, and because it's so you could graph that instead. So let's say we wanted to, let's see if this will work. It'll be 10.1, and when we add that, when I just changed that to 2 standard deviations, and what ended up happening here was this error bar doubled in size, which now represents 95% of the data. If you wanted to go that far. But I'm going to go back to the standard for graphing anyways. And the way to interpret this is that if there's any kind of overlap between these error bars, then there is no significant difference. So even though the averages are different, if you notice that the error bar for Safeway falls between, I don't know, let's say about 17 and 30, and the Chips Ahoy also fall, 68% of the data falls between 12 and 27, then because there's an overlap on that number line, there's no significant difference. So if we were actually looking for, if we saw a significant difference between our data, we would see bars and error bars on those columns that do not overlap on the y-axis there. But according to our data here, there is no significant difference. And notice I did not say insignificant, I said no significant difference. And that's the way we talk in statistics. So use this. I hope that this helps you. And if you have questions, ask Ms. Gunderson, and we can get together again or figure out some other way to help you and prepare for a regional science fair. All right? Good luck, everyone.